Good day to all of you. Our lesson for today is how to use WEKA in classification. To demonstrate that, let's go to my paper first. Go to Google, go to Scholar, and let's go to my account. So this is my account, and these are the papers which I have already published from the previous years. We will use this paper. Let's open it, download and open it. In this paper, I have used the objective of this paper is to classify copy bin species using image processing, artificial neural network, and k-nearest neighbor. So to demonstrate it in WEKA, I will use image. The data set is already been extracted using image processing. The pictures of the copy bins had already been extracted using image processing. And instead of classifying it using artificial neural network, and k-nearest neighbor, we will use the WEKA classifier. In this paper, I use 80 samples for Robusta, 80 samples for Excelsa, 80 samples for Liberica. 60 were used as training samples, and 20 are used as testing samples. These are the extracted features. This is the range for area, perimeter, equivalent diameter, roundness percentage. So research is searching again. So let's redo this paper using the same data set, and let's see whether the result will be higher percentage accuracy than the artificial neural network and k-nearest neighbor. So let's begin. To do WEKA, first you need to download WEKA. So go to Google, type WEKA, and download your software from this website. So need to download. There is the stable version. For Windows, click here, then download. It will take you less than 10 minutes to download this and install it in your computer. I have already done that procedure, so I will not be going through the downloading and installation process. So let's go to WEKA. So let's go to WEKA. WEKA 3.95. So open it. So WEKA is a bird, and also a program from University of Waikato. Let's look on our data set. This is our data set. Okay, mamaya tayo doon. This is a data set. I have 80 samples Robusta, 80 samples Excelsa, and 80 samples Liberica. So, as for the 80 samples, we will divide it into two groups, the training samples and the training samples and testing samples. In my paper, I have used 60 samples for training and 20 samples for testing. So it is in Excel. So before we can use it into the WEKA, we need to save it first into CSV. File, save as. So CSV. Change the file format, save as type CSV. Then save. So this is the data now in CSV. Okay. So now we are now in the WEKA environment. Let's open first let's convert first the CSV file into an ARTFF files. The reason behind this is only ARTFF files, ART files are being processed or readable by the WEKA. So let's open first. CSV can be opened, but the file format that is being processed by WEKA is ARTFF. So let's go to our folder wherein we have saved the dataset. So it's here. So look for the CSV data files. So this is the dataset in CSV format. So file of type, let's open it. So this is the CSV file. But we need to convert this into ARTFF files. File, save as ARTFF. Okay. Okay, now we will use the dataset into classification. Go to Explorer, open file, let's go to this is the ARTFF files. Let's open it. So we can see these are the features. 4 features: area, perimeter, equivalent, roundness, and the fifth column is the class. Can visualize it. Okay. So it's now ready for classification. Let's go to classify. So we will change the cross validation false to 4. Because 80 divided by 4 is 20. That means 60 samples will be used for training and 20 samples will be used for testing. So change the cross validation false into 4. So let's choose you can choose from here which classifier will give the highest accuracy. So I'll choose let's try bias net. Choose, close, then start. So for the bias net, this is 91.7695% accuracy. Let's choose naive bias. Then start. 92. Bias net is 91. Naive bias is 92. Let's try another classifier. This is not a good classification accuracy. So let's choose another classifier. Yes. So start it. It's 92 0.5926%. So, okay, let's choose another one. So let's try logistic. So classification accuracy is 81.815. Time to build the model is 0.08 seconds. This is important because when the two classifier are have the same accuracy, the better one is the faster classifier. So you can also include this in your table, in a table in your paper. So let's try another one. Multi-layer perception. Then start. So multi-layer perceptron is a neural network. So I think it will take time to train. So let's wait for it. Let's give time to let's try to wait for this. So time taken to build a network in multi-layer perceptron. So what is the classification accuracy? So for the multi-layer perceptron, we have not seen the classification accuracy. So let's try. Let's choose another classifier. The simple logistic. Let's stop the multi thing. It will take very long time for the multi-layer perceptron because this is an artificial neural network. We choose a simple logistic. We start. So this is 93.4156. 93.4156. Let's choose another classifier, SMO. Start. This is 92.596. SMO. For the lazy, IBK. Start. 91.358. For K-star, start. This one is 90. LWL, this one is 89. So let's try Logit Boost. This one is 91.4156. Logit boost, same as simple logistic. Okay, choose multi-class start 87%. This is 88% for the meta multi-class classifier. Multi-scheme, so this one is it's the classification accuracy is only 32%. So this is not a good classifier. So on and so forth. So there are so many classifier to choose from. Let's try J48. Start. So for the J48, this is the highest so far, 94.6502. Let's try LMT. Start. Uh, 93.416. Let's try random forest. 93.416. Random tree. Start. Very low classification accuracy, 64.69091. Rep 3, 32. So let's try this one. Decision stump. Start. 63. So out of the classifier here that we have tried, that I have tried, trees is the highest with trees. J48 is the highest with 94.6509. So that's how we use classifier in. That's how we use the WEKA machine learning algorithms in classifying certain classes. So I hope you learned something from this video, and thank you very much for watching.